Hey guys, today we are looking at 5.7, which is all about systems of linear inequalities. So yesterday, you guys know we went through 5.6, which is all about graphing two variable inequalities, which are just linear inequalities. Today, obviously, we're looking at systems of linear inequalities, which, just like a system of equations, was a set of two equations that use the same variables. A system of linear inequalities is a set of two or more linear inequalities using those same variables. We know that in a system of equations, a solution of that equation, a solution of that system is only a solution if it's true for both of the equations in my system. The same thing applies here for a solution of a system of linear inequalities. It has to be an ordered pair that is a solution to all of them. So just like yesterday, we're going to be going through and graphing each of our inequalities, identifying their boundary as a solid or a dotted line, and then shading either above or below. But here, we're going to be doing that for both of my both of my inequalities. And then the solution to my system of inequalities is going to be where those two shading parts overlap. So it's shaded by both of my two inequalities. So I'll show you a couple different ways that I will do this. So we can differentiate between where is shaded by one, where is shaded by the other, and then where it's shaded by both. And then for the rest of them, it's going to be up to you on how you want to note that. But you do have to make sure that you're able to distinguish between what's shaded for one, what's shaded for the other, and what is shaded for both. But other than that, it's really just going through and doing two inequalities on the same set of graphs. So if I'm going to go through and graph this system of inequalities in box 2 here, I'm going to go ahead and make this bottom inequality my blue graph, and my top inequality I want to do in red. So if I'm going to go ahead and graph we'll do my top one first in red. So that one, just like we did yesterday, y, I'm going to imagine it with an equal sign, y equals x plus 2. Well, that graph has a y-intercept of positive 2. And since I don't see a slope out in front of my x, we know there's a little imaginary 1. So my slope of 1 tells me from that y-intercept, I go up 1, right 1. And there is my other point. So then I'm going to go ahead and grab my ruler, connect the dots with a nice straight line. Now here, before I can actually draw that line, I want to look at what inequality my graph, or my inequality has, what symbol it is. So in this case, it is just less than for my top inequality. So remember, like we talked about yesterday, less than told me it should be a dotted line. It does not have the or equal to. So I'm going to go ahead and make a dotted line, put my ruler away, arrows on the end. And now from here, the shaded part, I've got those two options. I can either look at it and see, okay, my y is less than that boundary x plus 2, so that should be shaded underneath. Otherwise, we also could do that test point method where we pick out a point. I usually like using 0, 0, and checking to see if it makes my inequality true. So if I plugged in 0, 0, 0 for my y value, 0 for my x value, tells me 0 is supposed to be less than 2, which is true. 0 is smaller than 2. So the origin should be on the shaded part of my graph. So option number 1 on how we can do this, since I'm trying to shade this part with my red graph, if you have two different colors and you want to differentiate it that way, then you can just go through and shade all of this area down below. Now I'm kind of combining two different methods together here just to demonstrate the different options we have. Because what I like to do is kind of like cross-hatching. If any of you guys have done that in art class yet, or know what cross-hatching is, where we draw in two different directions that are kind of perpendicular to each other. So here I'm going to shade all in this direction for my red graph, and then for the other equation, for my other inequality, I'm going to shade it diagonally the other direction. Because then all of my places where those shading lines are crossing, then we know that that's the solution to my system. Okay, but I'm going to go ahead and move on to my bottom inequality in blue. So that inequality originally, y is greater than or equal to 2x minus 1. So that minus 1 tells me that's my y-intercept. Negative 1 is my y-intercept. Since my slope is positive 2 from that y-intercept, I'm going up 2 and then right 1. So up 1, 2, over to the right 1. And then I'm going to go ahead again and grab my ruler, connect my lines the best I can. That looks good. This one should be a solid line since my inequality was or equal to. So solid line all the way across there. Arrows on the end. And now again, I'm going to go ahead and test to see where my graph should be shaded. I think it should be shaded above because it's greater than. But just in case, if we wanted to test 0, 0 again, which is right there at the origin, if I plug that in, 0 is supposed to be greater than or equal to 2 times 0 minus 1. So 0 is greater than or equal to 0 minus 1, which is just negative 1. So that is true. Once again, I know that that is true. So I can go ahead here. Oops, I accidentally erased my highlighting here. There we go. So now my blue graph should be shaded above. So the way that I do this, I kind of go opposite directions this way. Obviously, I'm shading in two different colors. So if I want to do it solid shading all the way across, if I have a blue and a red shading, that should mean everywhere that I see purple would be my solutions. But you can see here what happens down in this area, this little kind of triangle space. You've got the shading going in both directions. They kind of overlap each other and cross each other up. That's going to be where my solution of the system is. That little slice right there, where I've got shading for both of my two inequalities. But that's it. It's just graphing two of them at the same time. So not really that much different from what we did yesterday. It's just two simultaneously. So let's take a look at another one. Down here in box 3. For box 3, our top inequality, I'm going to do in red. Our bottom in blue. So my top one in red, y is less than or equal to negative 2x minus 1. So negative 1 is my y-intercept. Since my slope is negative 2, I go down 1, 2, right 1. Go ahead and grab my ruler. Line up my graph. It is just less than, so it should be a dotted line. Oops. Should probably go all the way to the edge there. I need to zoom out a little bit further. There we go. Oops. So now I can put my ruler away. Awesome. And then shading wise, again, I've got my y by itself, so I can just follow that same rule. It's less than, so it should be underneath. So all of this area down here should be shaded. You can also do the test point when you plug in 0, 0, or whatever point you choose. If I use 0, 0, it's not true, so that should be the unshaded part of my graph. My blue equation, or in this case actually my blue inequality, I could try and do the boot method on it. Right, if I do my boot method on x to find my y-intercept, I get a y-intercept of 3, which is fine. But it doesn't work out nicely for my x-intercept because I end up with a fraction. So what I want to do here, just do a little bit of rearranging. I'm going to put this into slope-intercept form first, and then I can go ahead and graph. Because that gives me 2y is greater than or equal to negative 4x plus 6. And then I divide by 2 all the way through. So my rearranged equation for my bottom one in blue is y is greater than or equal to negative 2x plus 3. So positive 3 is my y-intercept. My slope is negative 2, so down 2, right 1. I'll go ahead and grab my ruler, connect my dots, make sure my full graph can be seen. There we go. Line it up. This one is or equal to, so it's going to be a solid boundary going between the two. Arrows on the end. And now my inequality was greater than, so it should be shading above. So now I go in the other direction. Just kind of going this way in case I don't have multiple different colored pens. I would be able to see, in this case, that where they overlap would be my solution. But this is kind of a weird one because they don't overlap at all. They don't intersect anywhere. My blue shaded is completely separate from my red shaded. So this is one of my special cases where my solution is actually no solution. There is no overlap. Now that's not something that you need to necessarily note on here, You don't need to make a separate statement for it being no solution, or if they were completely overlapping, it would be, infinitely many solutions. But something interesting to note, it is possible for us to not have any overlap and not have a solution to my system. All right, box 4. So box 4, our last one here, is a working backwards problem. Now I'm starting with the graph, and you have to write the inequalities based on those pictures. So it's going to be pretty much working backwards from an inequality like I usually would. I'm going to find my slope and my y-intercept to write my equation line first, and then I'm going to decide how and which inequality is going to be replaced for my equal sign. So I'm just going to go ahead and pick one, doesn't matter which. It kind of comes out gray on yours and mine as well. So if I just say that this is line A, I'm going to do that one in blue, and then line B, I'm going to do that in red. So for that inequality for line A, my y-intercept right here is at 0, 0. So my y-intercept is 0. So for this one, I'm trying to do y equals mx plus b. So my b value is 0, intersects at 0, 0. My slope of this line is up 1 over 1. And it looks like my graph has scaled consistently, still just ones. So that means my slope is just positive 1. From here, I can decide, or I have to figure out which inequality is going to be replaced in my equation, because it's looking like just y equals 1x plus 0, which we could totally clean up if we wanted to, and just say y equals x. But now we need to worry about what inequality is going to get replaced here for my equal sign. So we know it's a dotted line, so it should just be less than or greater than. And in this case, since the shading happens underneath my line, it should be less than. Less than is under, greater than is over. So here, this should just be y is less than 1x plus 0. Or if you wanted to just clean it up a little bit, y is less than x. That's the simpler way of writing it. My bottom one is a little bit trickier, my one in red here, because my slope, this is just a horizontal line, my slope is 0. My y-intercept here happens at -2. So the equation version would just be y equals -2. There's no slope, so my x value goes away. But now I need to decide which inequality is going to be replacing it. So I see that it's a dotted line, so it's definitely going to be, it's a solid line, so it's definitely going to be or equal to. And for this one, since I'm shading above that boundary, it should now be a greater than. So greater than or equal to -2. And that's how we handle it. We just figure out what the boundary is for my two shaded parts, and then from there replace my inequality in there for my equation. Alrighty, well, that's all I got for you guys for 5.7. That is also the last section in chapter 5. So tomorrow we'll be starting to work on getting ready for our test. Tomorrow will be review day. But yeah, that's all I got for you. Homework for 5.7 is page 278, 4 through 26, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you guys soon.